Let's go back to here then. There's a lot going on this screen, so we're going to take it slow and see if we can get everybody where they need to be. So we're going to talk about arcs today. And arcs as they relate to a circle. So we've talked about already a circle, which just for reference sake is not that pink thing. That pink thing is the interior of a circle, which is the area. We're talking about the black line that goes all the way around, the hula hoop. Okay? And so we're going to talk about arcs. And arcs, simply put, are just chunks of a circle. If I take that circle and I slice it up into little curved pieces, each of those curved pieces are what's considered an arc. Okay? And again, we're ignoring the green part because that's not part of the circle. That's a circle interior. Okay, so 3 different types of arcs. We have a minor arc. Minor arcs. Oh, wait a second. We have to talk about how to measure arcs. So we'll go down here to arc measure. Arc measure corresponds to the number of degrees of the angle formed from that arc. Okay, now that's a little confusing, but if we look here, I've got this 50-degree angle. And this angle here is formed by connecting 2 points on the circle to the center of the circle. That, by the way, is called a central angle. So the arc measure is the same as the central angle measure. So arc measures are measured in degrees. The biggest arc you can have would be 360 degrees. The smallest arc, theoretically, would be 0. Now, notation for that. We say arc AB, and we put a little arc symbol over it. Go figure. When we're talking about segments, we put a segment over it. Talk about rays, you put a ray over it. Arcs, you put an arc over it. Okay, so the measure of arc AB in this case is 50 degrees. So, a minor arc would be any arc, sidebar here. Have we talked about that symbol before? Yes or no?
Yes, it means circle.
No, this means circle. That's a theta. It's a Greek letter, commonly used to refer to an angle. So a minor arc goes from 0, but less than 180. So this arc AB is what we would consider a minor arc. Major arcs go from 180 to 360. Now, major arcs are a little bit different. So if I say to you, if we start all over again and I say to you arc AB, there's a problem there. Because one of those arcs could be this one in orange, but I could also have arc AB being this one, going all the way around the other direction. So how do we distinguish between the two? Well, one of them is a minor arc, one of them is a major arc. The difference is that major arcs, you need 3 points to name that major arc. So for instance, we would use arc ACB and put an arc measure over it. Minor arcs, 2 letters. So a minor arc says go from A to B as quickly as possible. Major arc says go from A to B but pass through C along the way. Does everybody understand that? Yes? Okay.
Yes.
Good. Then a semicircle. What's a semicircle? A semicircle is when theta is equal to exactly 180. Also 3 letters. Why 3 letters? Because we have to know which side of the circle to go around. Okay, something like K, L, J. Questions on the naming? Okay, so minor arcs are smaller, major arcs are bigger, semicircles are half of a circle. We talked about arc measure already. It matches that central angle. So if, for instance, I say, let me change colors here. We'll go to white. If I do this, and I say that this arc BC is equal to 110 degrees, then I also know that this angle has to be 110 degrees. So the central angle and the arc have the same arc measure. Okay? Beautiful. Now, let's talk about how to find arc length. First of all, let's talk about the difference. Arc measure is an arc measure, or sorry, that's a true statement, but it's dumb. The arc measure is an angle measure that represents the number of degrees of the circle that we're taking. The arc length is an actual length. If this were a big circle, the arc length for AB would mean how far do I walk if I go from A to B. Okay, measured in inches, feet, yards, meters, whatever. So the question is, how would I find the arc length of arc AB? Give me some ideas.
Maybe you take distance from the center point to the edge or to the circle and combine with the angles.
Ooh, not a bad idea, but that would be scary because then we'd have to get some weird trig involved. We could get there eventually, but it would probably require some calculus. I mean, I could do some calculus. I don't think you want to.
Yeah, I don't.
Okay. Other ideas, anybody? I'll give you a hint. An arc is a chunk of a circle. No? Enya, question for you. Are you there?
Yeah.
Outstanding. If I asked you, could you find the distance from A all the way around to A again, would you be able to find that distance? If I said to you, okay, here's a giant circle, start at A, walk clockwise and come back to A, could you tell me how far you walked? You'd be able to do that, right?
Yeah.
What's that also known as?
The circumference.
Beautiful. And just for future reference, the circumference, refresh my memory. What's the formula for the circumference?
Times diameter.
Pi times diameter, good. D pi or 2 pi r. Excellent. So you could calculate the entire distance around the circle, yes?
Yeah.
Could I use that information to figure out how far it is from A to B?
Yeah.
How?
You could add up like the whole diameter and then subtract the part that you don't need.
Okay. So how would I do that? Here, let's do that. Wait, hold on. Let's do something else. Give me a second here. Let me get rid of this. Let me clean all this mess up. Go back to where we were. Okay, keep that there. Get rid of that. That's 50 supposed to be there. Okay, so we'll just do this. Erase that. Come back there. Okay. So let's see. That was 7 meters. That's X, and there's a 50 in there. Okay. All right, so let's do this. Suppose I went across the circle to this point over here. We'll get rid of C for a second. We'll call this point D. And could you find the distance from A along the circle all the way to D? And yeah.
Yeah.
How?
You would use the semicircle formula and find the circumference of the semicircle.
Good. Okay. What if I said, let's not go halfway around? So, by the way, hold on, let's take a break. Is everybody with her? You understand what she's saying? That semicircle is half of the circumference. Okay. So instead of going all the way around, or halfway across the circle, what if I made a nice 90-degree angle here? We'll call this point E. That's 90 degrees. Could you find this distance?
Yeah.
How?
You'd find the semicircle circumference and then subtract half from it.
Good. Okay. So you're taking half of the circle and then half of the circle again, also known as a quarter of the circle. Okay? Excellent. Now, the question is, going back to what we were looking for, going from A to B. So what she's done so far is she said the semicircle was half of the circle. The 90-degree angle is 1/4 of the circle. What part of the circle is the distance from A to B then? Anybody?
Is it like an eighth?
How do you know it's an eighth?
Because if you add 1/8 to it, it gives like 1/4. Well, yeah. I don't know. It's like the half.
Well, I'll tell you this. If that angle was 45 degrees, it would be 1/4. Or sorry, 1/8. But it's not 45, it's 50. But you're on the right track. This arc, AB, is a fractional part of the circle. The semicircle was a fractional part of the circle. The 90-degree arc was a fractional part of the circle. But the question is, what fraction of the circle is this 50-degree arc? How would I figure that out?
You have to use the circumference.
Good. Keep going.
Is it 50 over the circumference or 50 over the 360?
Beautiful.
Oh, okay.
It's actually 50 over 360.
Gotcha.
Okay. Now, for those of you that are confused, AM is arc measure. What did we just do? Well, when Enya found or talked about how to find the length of the semicircle, she said, well, that's half of the circle. Well, how do we know it's half of the circle? It's 180 degrees over 360 degrees. Then when we did the 90-degree angle, she said, well, that's 1/4 of a circle. Well, how do we know that? 90 over 360 is 1/4. So now we're saying, okay, I got a 50-degree angle. What fraction of the circle is that? It's simply the arc measure over 360. And as Daniel said, you multiply that by the circumference. So whether it's 1/4, 1/8, 1/2, 50 3/60ths, we can find the length of any arc on the circle if we know either the arc measure or the central angle measure. So in this particular case, we would get 50 over 360 times 2 pi times 7. And that would give us the arc length. Now, we're going to build on that concept. So before I go any further, does anybody need that explained a little bit more, or are you good to go? Going once. Going twice, sold. Okay, so how are we going to build on that? Well, we're going to do something nice and simple, and that is, based on what we just discussed, how would I find the area of that pink region? Let me get all this other riffraff out of here. Okay, and put back what we know. A, B, 50 degrees, and 7 meters. How would I find the pink area? Megan, ideas? Oh, so wait, somebody else. Go ahead.
Would you take that same fraction, 50 over the 360, and multiply it by like the area formula?
Lovely. Thank you, Elena. That's perfect. Okay, so, oh, by the way, this thing over here is what's called a sector. Okay, a piece of pie, if you will. The technical name is a sector. And if we want to find the area of that sector, as she just said, it's the arc measure over 360 times the area of the circle. So that idea of taking the arc measure over 360 continues to tell us what percentage, what portion of the circle are we referring to. If I put the whole pink thing back, it's easy. It's the area of a circle. Done. Pi r squared. This, however, is going to be, if you prefer, we can do this also. If for some reason you forgot that the area of a circle is pi r squared. And we can use that to build upon different problems, depending on whether we're looking for arc lengths or sector areas. And eventually, we're going to get to something different. I don't think you're ready for it yet, but eventually we're going to do something. Let's see, come over here, make that black. We're going to find the area of that guy. But that's for future reference, and we'll think about how to do that later. Today, I want to just do baby steps. Definitions of what arcs are, the three different types of arcs, how to label the arcs, how to find the arc measures, and how to find the arc lengths. And then on top of that, we've got the area of sectors. Okay? Don't overthink this. You're talking about percentages or portions of big things. So an arc is a chunk of a circle. A sector is a chunk of a circle interior. One is based off of circumference. One is based off of area. Okay, questions? Do you want to see a couple more examples, or are you good to go?